our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with the chemistry for class 11 part 2. That is your class 10th. We had done your class 9th, and we had even though we had done your unit 8 in terms of it of part 2, that is redox reaction. We had even though started with unit 9, that has been the hydrogen. Now we'll discuss in hydrogen as well. We have discussed about more in detail about hydrogen and positions of hydrogen in the periodic table, and then we had done your dihydrogen. We had started with the occurrence and the isotopes of hydrogen as well. We had done. So yes, we go for in the detail about it, and that is your atomic and physical properties of hydrogen. Then we'll discuss the rest of the topic, and that has been in terms of it. We'll discuss the preparations of dihydrogen, that is H2. So before that, we'll discuss some of the tables related to it, which is atomic and physical properties of hydrogen. Let's get started with atomic and physical properties of hydrogen. So with the same, we made a table here, and that is we'll be going for the first one, that is being the property. Then we have for the hydrogen, deuterium, and the another one we have tritium. So we go for the properties here. Now we go for the properties. Here we go. The first property we have relative abundance. It's in percent. That is, the hydrogen is 99.985. For deuterium is your 0.0156, and from tritium is your 10 to the power minus 15. Therefore, the another one which we have is your relative atomic mass. Which is gram mole inverse. For hydrogen it is 1.008. For deuterium it is your 2.014, and for tritium it is 3.016. Now the another property is melting point. By Kelvin, which is 13.96. For deuterium it is 18.73. For tritium is your 20.62. For another one, it is your boiling point. per Kelvin, which is 20.39, 23.67, and this is 25.0. Another is your density, which is gram liter inverse. That we have here is your 0.09, 0.18 and 0.27. Now for another one is we have enthalpy of fusion, which is kilojoule mole inverse, which is 0.117, 0.197. So that has been done. Another we have enthalpy of vaporization, which is kilojoule mole inverse. This is your 0.904, 1.226. Another we have is for enthalpy of bond, enthalpy of bond, which is dissociation by kilojoule mole inverse. At 298.2 Kelvin, which is 435.88, 443.35. Another we have here for internuclear distance, by m, that is 74.14 and 74.14 for the same. Now for another one which we have is your ionization enthalpy, which is kilojoule mole inverse, 1312. Another one we have electron gain enthalpy, kilojoule mole inverse, which is minus 73. Another we have is your, so with the same we go for it, and that is electron gain enthalpy, we had find it out. Now we go for the covalent radius. PM, which is 37. So with the same, here we go for it, and we'll talk about ionic radius. Which is PM, and that is 208. we go for it, and that is what we had find out for atomic physical properties of hydrogen here. Now we're gonna detail discuss about some of the things related to it, which is your preparations of dihydrogen, which is your H2, and we will discuss laboratory preparations of dihydrogen and your commercial productions of dihydrogen, as well as the properties of dihydrogen, which is your physical properties and the chemical properties. So uses of dihydrogen as well if it is not been exceeded. So now we're gonna for it. Preparation of dihydrogen, which is H2. So there are the number of methods for preparing dihydrogen from metals and metal hydrides, and here we go. That is the first we'll discuss about the laboratory preparations of dihydrogen. So laboratory preparation of dihydrogen that we're gonna discuss here. In the same way here, it is usually prepared by the reaction of granulated zinc with dilute hydrochloric acid, which is your zinc plus 2H plus will give you zinc 2 plus H2. Now it can also be prepared by the reaction of the zinc with aqueous alkali, that has been zinc plus 2NaOH will give you Na2ZnO2 plus H2. This Na2ZnO2 is your sodium zincate. Now we talk about further commercial productions of dihydrogen. Commercial production of hydrogen. Commercial productions of dihydrogen. The commonly used process that are outlined below. Here first we talk about for the electrolysis of acidified water using platinum electrode that gives hydrogen. So in the same way we'll be discussing that here in the detail. So here we go. 2H2O. Electrolysis traces acid base, which will give you 2H2 gas plus 2 gas. Now we talk about for the second one, where high purity is greater than, that is less than, or that has been greater than 99.95%. Dihydrogen is obtained by electrolyzing warm aqueous bottom hydroxide solution between the nickel electrode, and even though it is obtained as byproduct in the manufacture of sodium hydroxide and chlorine by the electrolysis of brine solution. During the electrolysis, the reactions that takes place are at anode, which is 2Cn minus, aqueous will give you Cl2 gas plus 2 electron at cathode, 2H2 liquid plus 2 electron, H2 for gas plus 2OH minus aqueous. The overall reaction will be 2Na plus aqueous plus 2Cl minus aqueous plus 2H2O liquid. It will give you this is going to be Cl2 gas plus H2 gas plus 2Na plus aqueous plus 2OH minus aqueous. So for reactions of the steam of hydrocarbons or coke at high temperatures in the presence of catalysts yield hydrogen, where it forms CN H2N plus 2 plus NH2O will give at 1270 Kelvin nickel, which is NCO plus 2N plus 1 H2. So example for the same, it will be like CH4 gases plus H2O gas will turn to 1270 Kelvin. For nickel, it is Cu in the form of gas plus 3H2 in the form of gas here. Where in the same way the mixtures of Cu and H2 is called water gas, as a mixture of Cu and H2 is used for the synthesis of methanol and a number of hydrocarbons. It is also called synthesis gas or syn gas. Nowadays, syngas is produced from sewage, sawdust, scrap wood, newspaper, etc. The process of producing the syngas from coal is called a coal gasification. Now we go for the reactions here that we'll find it out. So that is being your CS. Let's go for the same. So we are in the same way. We talk about it, and let's go for the same. So here we go for carbon plus H2O gas at 1270 Kelvin, carbon monoxide gas plus H2 gas that we have. Okay, so on the way same that the productions of dihydrogen that can be increased by reacting the carbon monoxide of the syngas mixtures with the steam in the presence of iron chromate as catalyst. So that will be carbon monoxide in the presence of gas plus H2O gas at 673 Kelvin in the presence of catalyst give carbon dioxide plus H2 gas. This is called water gas, where the shift reaction carbon dioxide is removed by scrubbing with sodium arsenidite solution. Presently, near about 77% of the industrial dihydrogen is produced from petrochemicals, 18% from coal, 4% from electrolysis of aqueous solutions, and 1% from the other sources. Now we talk about for another one, which is your properties of dihydrogen. We'll discuss one by one that. So here we go for the same. Properties of dihydrogen. Here we'll talk about for the physical properties. terms of physical property, dihydrogen is a colorless, odorless, tasteless, combustible gases. It is lighter than air and soluble in water. In its other physical properties, along with those of the deuterium, and are given that we'll discuss in the last class. In the same here, in this class only, we had discussed the table. Now talking about the chemical properties. So for the chemical properties, that the chemical behavior of dihydrogen, and for that matter any molecule, is determined to a large extent by the bond dissociation enthalpy, where the hydrogen-hydrogen bond dissociates enthalpy is the highest for the single bond between two atoms, that is highest for the single bond between two atoms of any element. What inferences would you draw from this fact? It is because of the factor that the dissociations of the dihydrogen into its atom is only near about 0.0851% around 2000 Kelvin, which increased to 95.5% or 5000 Kelvin, and also it is relatively inert at room temperature due to the high hydrogen-hydrogen bond enthalpy. Thus, the atomic hydrogen is produced at a high temperature in an electric arc and under the ultraviolet radiation. Since its orbital is incomplete with one s1 electronic configuration, it does combine with almost all the elements. It accomplishes reaction by loss of the only electron to give H plus here, and gain of the electron to form H plus H minus, and that sharing of electron to form a single covalent bond. Now the chemistry of the dihydrogen that can be illustrated by the following reaction. We'll discuss for the first reaction with halogens. A reaction with halogens. So in terms of reaction with halogens, we go for it, where it reacts with the halogen X2 to give the hydrogen halide, which is HX. So H2 in the form of gas plus X2, that is the halogen in the form of gas, give 2HX. This is in the form of gas, where this X is your fluorine and fluorine, chlorine, bromine or iodine. It could be any of the halogens. And with the same, while the reaction with the fluorine occurs even in the dark, so with iodine is require a catalyst here. Okay, now we go for the reaction with dioxygen. Reaction with dioxygen. In terms of reaction with dioxygen, it reacts with dioxygen to form water, and the reaction is highly exothermic. So 2H2 in the form of gas react with O2. It will give you it in the presence of catalyst or heating. Which will give you 2H2O in the presence of heat, and that is minus 285.9 kilojoule mole inverse. Now we talk about the reaction with dinitrogen. In terms of direct reaction with dinitrogen, and that is with dinitrogen it forms ammonia, 3H2 form gas plus N2 gas. It will give it 673 Kelvin to 200 atm in the presence of Fe. That will give 2NH3 form of gas. where the heat will be minus 92.6 kilojoule per inverse. This is the method for the manufacture of the ammonia by the Haber's process. Now we talk about the reaction with metals. In terms of reaction with metals here, with many metals, it combines at a high temperature to yield the corresponding hydrides, and it will be forming the reaction which has been H2 in the form of gas plus 2M gas will give 2MH in the form of solid, where M is an alkali metal. Now we will go for reaction with metal ions and metal oxide. So here we go. Reaction with metal ions and metal oxides. So with the same, so here in the same, it reduces some metals ions in an aqueous solutions and oxides of metals were less active than iron into corresponding metals, and that will be forming here is H2 gas plus PD2 plus aqueous will give PD in the form of solid plus 2H plus aqueous. Here Y H2 gas plus MXOY in place of solid will give XM in solid plus Y H2O in place of liquid. Now reaction with organic compounds, we have reactions with organic compound. In terms of reactions with organic compound, it reacts with many organic compounds in the presence of catalysis to give the usable hydrogenated product of commercial importance. For example, hydrogenations of vegetable oil using nickel as catalyst gives edible fat, margarine and vanaspati ghee. Then another one, we have your hydro formation, that hydroformations of olefins yield aldehydes, which further undergo reduction to give alcohol. So that is will be in the form H2 plus CO plus R CH double bond CH2 will give RCH2 CH2 CHO. The another one we have H2 plus RCH2 CH2 CHO will give you RCH2 CH2 CH2 OH that we have. Now we have another question as well that we'll have to solve it out, but with that we'll be solving it out this in the next coming class so that it will be helpful for you. And other than this chemistry, we are dealing with the physics part 1, where we had completed your physical world, and we are dealing with units and measurement. We surely be narrating up that one as well. We had completed your reasoning, wherein that we had completed your verbal reasoning and non-verbal reasoning. Coming towards quantitative aptitude, we had started with arithmetical ability, in that we had on 15 topic we are dealing with the computer-based numerical and statistical technique. We are dealing with the database management system, which is your ER diagrams as well. Coming towards your chemistry for part 1, we had done unit 1, which is some basic concepts of chemistry. Unit 2 is your structures of atom. Unit 3, classifications of elements and periodicity. In property, unit 4 is chemical bonding and molecular structure, unit 5 is your states of matter, unit 6 is thermodynamics, unit 7 is your equilibrium.